So good. You don't really think you work. You think that like I feel so much more. Really? Yeah. I just ran around for hours every day. Yeah. You so much. It's like, oh. As you said, we can. Yes. Yeah, that picture was a big over. Where were you? You definitely underdressed. We were underdressed. You know, yeah. No, but like cheap chocolate. Things. And it was like, thanks to this, where did this huh? Yeah. Eating their food. The really pressed a bunch of girls like kind of that. And they were like, so they all like, oh, then you ate your food. Like, stop eating your food, you just eat it. I appreciate it. Okay. So yeah, all of you but they would like take themselves and say like no, like on a personal software. I'm making the later tape videos for them. And I was like, they're all students. So these should be the bitch. They just don't care. Literally, all of it. No, I think he is. He's dumb. He's interesting. If he's not gonna communicate with me, we shouldn't like keep saying. He's relying on us, but he needs to be. Huh? Was it about me? I'm a dad. Okay, comment.
No comment.
No. I already. She got disappointed. Everything's from and 2 classes. I'm in.
It's almost fun, but
It's not like it's not that bad. It's just a lot of material. I feel like it's
okay.
I think I'll do good, but not because I'm like totally interested. You know, need a choice. Need like. Yeah, I think I know. I also want to. It's all.
What about the good things?
All right, let's go finance. Is there, any questions on the project? It's due, a couple people have turned it in already, but it's due on Sunday and then respond to 2 classmates by, Wednesday, next week. Any questions? Okay. Any questions on anything? Exam is 2 weeks from Friday. So we have chapter 9 this week, chapter 10 next week, and then the exam the following week. Any questions? Okay, chapter 9 adds exponential growth. We've done linear. Linear grows by the same amount each time. So like the first example I have on here, $100 per year. So each year you're getting the same amount. That's linear. Y equals mx plus b. Now we're going to start with a percentage. When it grows by a percent, you're making interest off of the interest. Therefore, it's exponential growth. One of the problems on your exam, what's the difference between linear and exponential growth? Linear grows by the same amount every time. Exponential grows by a percent, so you're making interest off of the interest. Or losing if it's a decay. Okay. We're going to look at first example, investing $1,000 and you get $100 per year in interest. So after the first year, if you put $1,000 in and you're getting $100 per year, how much will be in the account after the first year?
That's it, 100.
100 more, 1,100. And then the next one will be 100 more than that one. 1,200. So each time we're adding $100 to the one before. And we're going to use Excel today to have it calculate, because when we're only doing 4, yeah, that's not very hard. Writing it by hand, but if you're doing 20 months or 20 years, you don't want to write all of those. Computer slow down. So at the end, we would have $1,400. At the end of 4 years, we would have $1,400 in the account. Each year, it's growing by the same amount. That's what made it linear. So it's linear growth. Linear is y equals mx plus b, what we've been working with the last 2 chapters. The slope is what's increasing 100 per year. And that's why the M is 100. The B is your starting amount. We started with $1,000. So then with this equation, we could find out how much in 100 years or any amount a year. Now, it doesn't have to always be years. It could be months. It could be every other month. However, the deposits are made. Did everyone get the sign-in sheet? So linear is what we've been doing. What do we use? We use the payment, electric bill payment. Any questions? Anyone else? Attendance? This one we're increasing by 8%. Remember, when we have an increase by 8%, find 8% of it and then add it on, or you can use the 1 plus trick. So if we use the 1 plus trick, 8%, remember, has to be written as a decimal. There's. So we take the one before and we multiply by the 1 plus trick. And that gives us 1,080. Now the next time we're increasing it by more than 80, it's actually going up by 86. So each time it changes. Thank you. because you're making interest off of what you made before. That's what makes it exponential. And so the first year we made $80, but the next one we made $86.40. So each time we're making a little bit more than the time before because of that extra interest that's in there. That makes it exponential growth when it grows by 1%, so the amount's different every time, or decreases by 1%, same thing. The balance, when you're trying to find the formula, because we used y equals mx plus b for linear. For exponential, it's the initial amount, and then you can use your 1 plus trick or minus if it's a decrease, and the time. So in this one, our starting amount was 1,000, 8% written as a decimal, and I used T for years. You could have used Y for years, you could use M for months, it's up to you. So this is a formula you want to memorize. So if you have, I recommend a sheet of paper and write all your formulas on it, then you have them to keep looking at to study for the exam. But it will not be given on exams. I think the main formulas right now were the linear, y equals mx plus b, and this one. There's a house payment one next chapter, but I will give you that formula on the test. Any questions? There's also a rule of 70 and 72. When you go to put money into account, or they're trying to get you to deposit into certain accounts, they'll tell you how long it takes your money to double. Now there's a formula you can use, but you can also use this, and it's pretty accurate. If your percent is 5% or below, you use rule of 70. And if it's greater than 5%, you use the rule of 72. And all you're doing is taking that number, 70 or 72, divide by the percent, not the decimal, but the percent. You may have already used this if you took business class. If you're a business major, you should have already seen this. So it splits at 5%. 5% and below uses 70. Above 5% uses 72. Any questions? And we'll do it with an example. Now, we used 1 plus trick. Relative change is just that trick. It's telling you whether it increased or decreased and what the percent was. So if we look at this example, y equals 320 times 1.04x. If we want to see how much it increased or is decreasing by, you just take the part that has the exponent on it, 1.04 in this case, subtract 1 and we get 0.04. It's positive, so it's an increase, and then multiply by 100 to get the percent. So if we're given the equation, we can still find if it's an increase or a decrease and the percent. We can also find the starting amount, which is the value that's not with the exponent, in this case 320. We're going to do a few examples. Is there any questions on finding it? So just take whatever has the exponent on it, subtract 1. If it's positive, it's an increase. If it were negative, it'd be a decrease. And then multiply by 100 to get your percent. Okay, if we look at the first example, or the one on the top, what is the initial amount? Anyone? It's the amount that doesn't have the exponent. That's what we're starting with, 120. Now the relative change, take the part that has the exponent, 1.07, subtract 1, and get 0.07, which is positive, so it's an increase, multiply by 100 to get the 7%.
In the homework, it has these written as like P equals 120, then a capital X. Is that times or is that X?
Oh, I didn't take those out. That is times. Yeah, the book had, but since I've kind of gotten away from the book, I forgot they were still there. So like that first one, some of the homework might still have that X there. I tried to take it out. This is not a variable, it means multiply. This pen's terrible. Any questions though? So on the homework, they may still have the X's in there. I pulled them out of here, but in between here, there'll be a capital X. That just means multiply. I think the person that wrote the book was not a mathematical person. And so some of the things that shouldn't be there are there. I didn't say that. Okay, so go ahead and try the next three. Those who are online, what we were talking about in the homework, there's a capital X right here. That just means multiply. So for the second one, what is the initial amount? Anyone?
472.
472. And then is it an increase or a decrease? Increase, because when we subtracted one, we got a positive. And what percent is it?
36.
Nice. So we took the 1.36, subtracted 1, and got 0.36. It's positive, so it's an increase. Multiply by 100 and get 36%. How about the third one? What is the initial amount?
521.
And then the relative change, increase or decrease?
Decrease.
Notice when you subtracted that 1, you got a negative, so it was a decrease by how much?
28.
28%. So if we take the 0.72 and subtract 1, we get a negative, so that means decrease. Multiply by 100 and get 28%. So when this is less than 1, this part with the exponent, it's decreasing. When it's greater than 1, it's increasing. Last one, what's the initial amount?
1,000.
Increase or decrease?
Decrease.
By how much?
96.
Decrease by 96%. Because when we subtract 1, we get a negative 0.96, which means a decrease of 96%. Any questions on that? There'll definitely be one on the exam. If you want to open your Excel file, you want to open an Excel file and label A, B, and C. We want to see balance 1, we're going to deposit $1,000 and they're going to get $100 a year. If they do get $100 a year, I probably kind of already said this, is it linear or exponential? $100 per year. It's linear because they're getting the same amount each time. And the 8%, kind of already said this earlier, but the 8% is exponential because it's growing by 1%. So I've said it probably at least 3 times now that it's going to be on the exam. All right, so open your Excel file, put year, balance 1, balance 2, start, and they're starting with 1,000. First, we're gonna mark the years. So where, where I have my block, but right under the start, you wanna put 1 because the first year, we opened the account, we got 1,000, that's why it says start. At the end of the first year, then we'll have our interests in there, so we wanna put a 1 here. Now we want to go 12 years, but we don't want to put 1, enter 2, enter 3, enter 4, enter. Because what if we have to do 50? So what we want to do is write a formula. When you're writing a formula, the first thing you do is use an equal sign. So we want to put the equal sign. And then you want to click on the 1 above because we want to take the 1 above and add 1. That will make it a 2. And then we will drag the formula down and it will keep taking the 1 before and adding 1. So we have the 1 to start with. Then in 4A, you want to put equals, click on the 1 above. You could also type A3 if you wanted, but it's easier just to click on it and then add 1. When you hit enter, it should have a 2 there. Is everyone getting a 2? What I'll do on homework, you'll have to attach the Excel file so I can make sure you use the equations. So hit enter, and we got the 2. Now you want to click back where you made that formula, so where the 2 is. Now there's 3 different plus signs you can get. You can get this one, kind of looks like a red cross symbol. Then there's the one with 2 arrows, like that. But if you go in the corner, there's a thicker one with no arrows. Now you want to left click and drag down to A14. We're going to 14 because we started 2 below so that we can get, it said 12 years. So I typed in equals A3 plus 1. Then I went to this corner and I dragged it down. Oh. Is everyone getting 1 through 12 without typing 1 through 12? Click A10 and what formula is there? So look where A10 is. This is something I would do on homework or, well, if we use the computer in the exam, I would. A10. So then you would click on this one and write whatever formula, what formula you see. So if I click on A10 right here, I have up here where the formula is, f sub x is for your function, equals A9 plus 1. And that's what you would write, equals A9 plus 1. Any questions on that? Type a formula to show the total after $100 that is made that year. So we want to type a formula at B3, so right here, that will take the balance and keep adding 100. Start with an equal sign. You want to take the one before and add 100. And then drag it all the way down for your 12 years. We put equals, we click on the one before, and then we want to add 100. So that in that spot should be 1100. And the next one, 1200, 1300. So we hit enter. Any questions on typing it in? Then click on the one again that has the formula, go to the very corner and drag it down. So at the end of 12 years, we'll have $2,200. Any questions? If you click on B10, see what formula is there. So here's the 10, go to B right here. I have equals B9 plus 100. Is that what everyone has there? So when you click on B10, you should have, it's $1,800, but the formula at the top, F sub X here, should be equals B9 plus 100. How many years did it take to double? Anyone? Well, we started with 1,000. Doubling would be how much? 2,000. And 2,000 is the 10th year. So it took 10 years to double. Any questions? For the next formula, remember we need to multiply in that one. Multiplication on Excel is the asterisk. Parentheses will not multiply and X will not multiply. You have to use the asterisk. So we want to increase by 8%. Remember, you use your 1 plus trick. So we put our equal sign, the one before, and then we need to multiply by, so asterisk.
Excuse me, do you know where it's
1 plus 8% as a decimal. Now, if you wanted to just put 1.08, that's fine also. But to multiply, you do need to use your asterisk. Any question? So equals the one above, which is C2, and asterisk times means times, and then you can put 1 plus 0.08 or 1.08. And you should get 1,080 when you hit enter. Any questions on the formula? So it's just the starting amount, the amount before, times 1 plus trick. Or if it's a decrease, 1 minus. And then take it and drag it down. Yep. To make things narrower and wider in your columns, you can go right here where it shows arrow right and left and make it wider. You can make it narrower. This one has a lot of decimal places because I did that. What you can do, you highlight it first, which is already highlighted, and then you right click and go to format cells. So if you ever need to change your data to integers, 2 decimal places, 1 decimal, whatever you want, highlight the data first, right click, go to format cells. I use number. I don't use currency because formulas, it doesn't always work nice with formulas. So I would use number and then however many decimal places you want. Since it's money, I'm going 2 decimal places. There it is. Any questions on that? If we click where C10 is to get the formula, 10 is here, C is here. That's where our 1850 is. The formula's up here, equals C9 times, and then in parentheses, 1 plus 0.08. Any questions on that? Everyone's getting the values, okay with the formula? How long did it take to double?
9 years, about.
Almost, we need one more dollar, but yeah. At the end of the 9th year, you've almost doubled. You need a couple more days to get that dollar. So 9 years, or I would accept either one. Technically, it's 10 years. The 9th year, you haven't really hit it. Would we use the rule of 70 or 72 to find the estimate?
72.
72 because it's more than 5%. We were using 8%. So to use the rule of 72, take 72 and divide by your percent, which was 8. 72 divided by 8 is what? 9. That's not always that close, but it's pretty accurate. And we technically need a little bit more than 9. But it doesn't matter how much money we put in there, it is still going to double at almost 9 years. So if we put, let me mark the 9 years. If we took this 1,000 and put I put 200,000, so doubled would be 400,000. 9 years, almost doubled. It took the 10th year, but it's still, oh, that was 11th. Should be the same. Shouldn't be that far off. Oh, no, it is. I'm looking at the wrong one. It is the 9th year. The end of the 9th year, you're almost there. And any questions on that? So when you're finding the amount of money to double, you don't need to know how much you're starting with. You only need the percent. It will always be approximately the same. No matter how much money I put in that account, it will take a little over 9 years to double. Any questions on that? Okay. We're going to look at a decrease also. So if you do want to keep this so you have it, you can just click the plus sign and it'll give you another sheet. We want the age, and we're going to use years, the value 1 and value 2 of a car. We're going to look at a car that we bought for $20,000, and the first one, it decreases by $1,800. The other one decreases by 13%. Is value 1 or value 2 linear? Mm-hmm. So value 1 is linear because it's decreasing by the same amount every year, $1,800 per year. The other one is exponential because it's decreasing by 1%. They also call it an exponential decay because it's decreasing. We start with our age. Will value 2 ever reach 0? Well, let's find the things first. So the first thing we want to do is start with year 1. So at the end of the first year, and we're going to go 6 years. So make a formula and then bring it down so it shows 1 through 6. equals the one before, and then we're adding a year. So we put equals A3 plus 1 and drag it down so that we have 6 years. Any questions? Value 1, we want to decrease by 1,800 per year and then drag it down for the 6 years. And the other one, we're decreasing by 13%. So when you use the 1 plus trick, it's really a 1 minus because it's a decrease. For the formula, just remember an equal sign. Click on the one before, and then how do we decrease it by 1,800? Subtract. So 18,200 the first year. Click back where your formula is and drag it down. So it's worth $9,200 at the end of 6 years. Any questions on that one? Okay. The other one, remember to use an asterisk to multiply. And because it's a decrease, you'll use 1 minus the percent. So we put our equal sign first, click on the one before, and then asterisk to multiply. 1 minus 13% is a decimal, 0.13. That what everyone typed. It entered, you get $17,400. Click back on where the formula is, drag it down. Now, when something is decreasing by an exponential amount, it will not hit 0. Eventually, the computer will round it. So like this one, if we drag it down, it's already past 0. It's getting in the negatives. Whereas this one, exponential, it's getting smaller, but it's not hitting 0. Still haven't hit 0. So exponential decay technically never hits 0. If we were graphing, there'd be an asymptote on the x-axis that it approaches it, but it never reaches it. Eventually, it will just round it to 0.
Yeah, and considering it's county, technically, eventually it will get so because it'll be less than 0.5%.
Right. But it,
I mean, technically it can reach 0, but it's as as y approaches 0, x approaches infinity. So
right.
it kind of
If we did a limit, it
Yeah.
would hit it.
Yeah.
Mhm. Any questions on using the formula, using Excel, plugging everything in? Not too bad. Any questions? That's the last one. Any questions on the project? No, I can't believe it. Okay. When you're doing the project, real quick, on this one. And you have your values. Let's see. L equals So if I have this list of values, when you're doing your histogram, don't make it only one width because then it looks just like a bar graph. So when you do notice it's not showing it. Use the little magnifying glass to, oh, see how that looks just like a bar graph. We need to change our width. So you just click here. Right now it's by ones. Maybe I should go by fives. So try different things. That looks a lot better. And see, change your width so it works better. 10 might be too much. Oh, that's not bad either. But depending on your data, use that width. Do not make it just one, simply because then it just looks like a bar graph in some cases. So to change your width, just click on where it says width and then it'll open this, but it's comma and then however many units you want it to count by. So it's counting by, there's 10 in between each one, this one. The other one was 5. Try different ones, see what looks good. For your box plot, if you want to show both of them together, then you want to offset it. If you put it in the negatives, it'll move it down here. So I can make it like, let's see, -5 maybe? Maybe that's too much. -3. Okay, there it is. It's coming. And then exclude outliers. Take that off. So I don't have any outliers. But if you did, you're going to have a bunch of points there. So then just have it stretch out so we can see how much it's stretching rather than getting rid of the outliers. So if it says exclude outliers, just get rid of that. Offset it if you want to put them both together, or you can do them both separately. And the height is up to you. Any questions on that? That was the only thing I noticed on a couple of the ones that students turned in. Or sent me pictures to see if it was correct first, which is fine. Any questions? So I think 3 people turned them in and they're really interesting. It's due Sunday. If it's late, then that's 5 points. You've had 3 weeks to do it, I think, or 4. On Sunday, actually probably Monday, because if I open it on Sunday, someone's going to post project 3 and project 4. So on Monday, I will open the last project. There's 4 projects. Any questions? Okay. If you do not have questions, I will see you on Wednesday. If you have questions on the group assignment, if you weren't here, let me know and I can help you with that. But if not, I will see you Wednesday. Yes. Write it in there so you remember. Less than points to the left. Not we're just great. You are welcome. No, that's fine. You too.
Good or about you.